Hello, this is Bruce Nielsen again. In our last few videos, we've talked about cosine similarity and how to use it for a semantic search. We've also talked about hierarchical navigable small world indexes and how we can use those to do an approximate semantic search in a tractable amount of time across a very large number of documents. We have also, probably at this point, if you've been following along, you've installed PostgreSQL and also pgvector, an extension to PostgreSQL, which will allow you to create hierarchical navigable small world or HNSW indexes. So we are really ready now to build a pipeline for retrieval augmented generation, or a RAG pipeline. However, your life will be a lot easier if you let me first introduce you to an AI tool called Deepset's Haystack. This is an excellent little tool that will really be very helpful in setting up a RAG pipeline. And so navigate over to the URL you see on the screen, haystack.deepset.ai. And from there, I will show you how to install it and how to get started. And then in this video, we'll talk about why it's useful and what we're going to do with it. All right, so here we are at haystack.deepset.ai. This is their homepage. You can see right off the bat, they show you how to do pip install haystack-ai. And really, today, that's all you're going to need to get started. I want to show you some alternatives, though, of how to install this that might be useful in the future. But this is probably enough. If you really want to get more details, you can click this Get Started with Haystack. And that will open up this set of instructions on how to install Haystack. And it even has this docs for installation. This is going to take you over to the documentation. Here's the documentation for installation. It's got to have a lot more detail there. But here's where you're going to actually find documentation for all sorts of things. So it's a useful thing to know about. Okay, so this is really how you would get started. So what is Haystack? Well, by their own words here, they say Haystack is an open-sourced AI orchestration framework built by Deepset that empowers Python developers to build real-world compound agentic LLM applications. Wow, that is a lot of fuzzy buzzwords. Let me actually put it in my own words here. Think of Haystack as being a pipeline. So you're going to build, and this is an actual one I've built for my AI Karl Popper, something that has inputs. Here's the query string you can see, and here is the number of top results I want back. It's going to go to a component called query input, and then it's going to do some sort of work and then send that off to several other different components. And those components are going to do work. They're going to eventually collect them back together. Here's the doc query collector, sends it off to a re-ranker, eventually goes over here, streams it so that it can stream it and does a prompt builder, sends it to the LLM, and then you're done with the pipeline at the very end and you get the result back from the LLM. So Haystack's going to help you build these sort of pipelines made up, and I say pipeline, that gives the idea of they're all in a row, but obviously this is more like a graph, right? It's a complex graph where information is flowing from one component to the next, and you're doing some sort of output out of that pipeline at the end. But I want you to pay attention to this integrations up here. So click on that, and it's going to take you over to these integrations. Integrations are where Haystack has integrated with other popular artificial intelligence or document pipeline software. So there are two in particular well, maybe three that we're going to want to pay attention to. Here you're going to see that Haystack is integrated with things like Anthropic, Amazon. They're integrated with most of the popular things that you probably heard about. Azure. They're going to have OpenAI. So what we're going to look for, if you're following along with me here, I'm kind of assuming that you're trying to do this on a shoestring budget. So one you might want to pay attention to is Google AI. That's going to be the Gemini integration, or Hugging Face, the Hugging Face integration, so that we can make models. We haven't gotten to where we're going to do models yet, so I won't show you about these yet, but that's just so you know where to find those when the time comes. And then if we were to keep jumping down here, what we're going to find is this pgvector integration. So that's the one we're going to want, because we want to install Haystack so that it comes integrated with pgvector. So let's click on that. And it's going to come to these instructions on integration with pgvector. And you're going to notice that it's going to explain how to do the install. Notice that the install is a little bit different. So pip install pgvector-haystack. You can always do this later. Like it's okay if you do haystack-AI and then install that first and then come back from the pgvector later. It's still going to work. It's going to have additional instructions on how to actually set up the variables, the environment variables, so that you're able to log in. I'm going to show you an alternative to that when the time comes. So just a lot of useful information here if you follow along with what I'm showing. So this is what we're going to do today. Now, just some useful things. My blog posts are really going to be helpful here. If you go to mindfiretechnology.com/blog and then maybe click on categories artificial intelligence, that's going to be all of my artificial intelligence blog posts. The ones that we're going to care about for today and that I will put into the show notes. You're going to be wanting to look for something like this: the environment setup for RAG using Python, Haystack, PostgreSQL, pgvector, and Hugging Face. I kind of made one blog post that showed everything together, so that's going to be a helpful one. Let me actually open that and show it to you. If you've been following along, you won't really necessarily need it, but it might be a good fallback so that you can see how to get caught up. What it's really showing you how to do is how to install for my toy application. If I go to my GitHub, there's going to be this GitHub/Bruce Nielsen, NIELSON/book search archive. That's my toy app. It is AI Karl Popper. It doesn't have to be AI Karl Popper. You can make it anything you want, any set of documents that you want. But it was the toy app that I created so that I could try out our Mindfire's open source AI stack and decide what was going to work best. So really, if you look back at the blog post I was showing you here, this environment setup, that's going to be instructions on how to make this work with the book search archive. So that might be a helpful one to know about. And then there are some other blog posts that might be useful for today's video. There's this RAG with Haystack and pgvector, part 1 and part 2. That's what we're going to be kind of at a high level talking about today. And then there's some other useful ones out there on the blog that you might find interesting, relevant to this, and some that we'll cover in future videos. Like for instance, there's this Google AI integration with Haystack. If we want to add Gemini in later, I will do a separate video about that. I just want to make you familiar with the resources that are available in terms of following along with what I'm showing here. Now, rather than having you set up the entire AI Karl Popper at this point, which has got way more than we need for this particular video, I've made a separate repo here. We've got github.com Bruce Nielsen/blog posts. And inside of there, I have put simple haystack demo .py. So simple_haystack_demo.py. This is what we're going to be working with. So if you want to pull down that repo and then work with my code here, or you can just use that as a starting point when coding your own. I'm going to do this inside of PyCharm. So I've got the simple haystack demo.py. And I will take you through exactly how to make this work, and then I will explain what the code actually does. Now, the first thing you're going to need to do is set up your environment. I'm going to be assuming you're starting from scratch, so I will quickly take you through what I had to install to make this work. You're going to need to do a number of pip installs before you can get started to set up your environment. Rather than go through these one at a time, I'm just going to give you a single line to use that for me worked to set up the environment. So pip install BS4, that's Beautiful Soup, that's used for parsing HTML, ebooklib, a library for reading EPUB files, pgvector-haystack, that's the version of Haystack that comes with hooks to work with Postgres, specifically with the pgvector extension for Postgres so that we can use vector embeddings and HNSW indices. NLTK, a natural language toolkit. Traphilatura, which I don't know what that is, and I'm not even clear why I need it, but it won't run, and it will tell you if you try to just install pgvector-haystack. It should have included everything it needed, but it doesn't, and then it will tell you you need to install this. So I've included it. And then finally, sentence-transformers. If you've got all those, now I've already done this before, so it's going to come back and say requirements already satisfied. But if you do all that together, it will set up your environment so that you can run my code here. So I have this code, this simple haystack demo, simple_haystack_demo.py, that's going to be out in the GitHub repo I just showed you. And what we're going to do is we're going to run it. And if you've got the environment set up correctly, as I just showed you, it is going to go out. It's going to log into my Postgres pgvector document store. And it's going to look for this query, which is, what is the difference between a republic and a democracy? It's looking for an answer within the Federalist Papers. So we can see it's warming up the text embedder, and it kind of went too fast there. It's initializing the document store, generating a response. And what it really does is it comes back with the best hits. So it came back with the top 5 hits. This one scores about 74%. And the content is, the 2 great points of difference between a democracy and a republic are, well, obviously that's a very good hit. And then it goes on to find some more mediocre hits, but it still comes back with the top 5 documents. So this is what we're trying to build right here, is something that's going to be able to take a document, in this case, an EPUB, but we'll do PDFs in the future. And it's going to put it into a document store in Postgres, in this case, with embeddings. And then we're going to be able to do a semantic search to pull it back out and get the nearest hits and be able to use those to feed to a large language model to give us the answers to our questions. Let me actually take you through this code now. We won't be going through it in fine detail. I just want to show you the main parts, but let me give you an overview quickly. So obviously at the very top, I've got a list of what you had to install. Then you have a group of imports. Then we have the class Haystack pgvector, which is the class that I wrote. It does some initialization. There's some properties, sentence embed dims, so that it's able to look up for itself how many dimensions that there are when it embeds a sentence, depending on which model you use. It's got a draw pipelines function. And then there's this generate response function, which is one that we really are going to care about. So I'm going to come back to that, but it's not too hard to see what we're doing. Basically, we're going to run the pipeline that we're going to create later. And then we're going to spew out the results. We're going to print it so it's in a format that we can see, and we're going to show it on the screen, which is what you just saw me do. We have a get secrets. That's something else I will probably show you in just a second. It's kind of a useful little trick. Instead of putting an environment variable, I made it so that I could actually just look up the password for Postgres out in a file somewhere. And then we've got this load EPUB. I don't need to go into detail on this. It was easier to work with EPUBs, and you will find that in the document store, there is a federalistpapers.epub, or you can just easily find it out on the Gutenberg project, which is where I got it from. So this is so that we can load it up. You don't need to know how that works, just it will work. So then we have the doc converter pipeline. So we've got 2 pipelines that we're going to be using today. One is actually going to take the documents and convert them into the right format so that we can put it into the database as embeddings. And then we've got a separate one called create rag pipeline, which is to read it back out and put it to the screen. And then we've got this initialize document store function that actually sets up and initializes the document store. Let's actually start there, because that always has to run. So basically, when you call initialize document store, it is going to come in here and it's going to try to set up a pgvector document store. I'm going to pass in some parameters, such as the table name that I want to be able to create and pull data out of. You can see that I have a few parameters set like this. I'm going to be using search strategy HNSW because we want to talk about hierarchical navigable small world. You can also see I'm doing a vector functionality of cosine similarity, just exactly like we've discussed. There's a connection string. I'll have to show you how to do that in just a second. And then you've got this, this sentence embedding dimensions, which I had it look up using, look itself up inside of the sentence transformers. And then I also say HNSW recreate index if exists. I always say yes to that just so that I'm always got a new version to set up. Recreate table. I pass a parameter in for that, but it tends to default to false. I don't necessarily want to recreate the table every single time. I want to be able to often just load it up and load in the data that's been previously loaded. But if I set it to true, it will wipe the table out and it will reload it from scratch using the document converter pipeline that I showed you above. We also give names to the for the indexes. So we've got an HNSW, a Haystack HNSW index, and a Haystack keyword index. This is for the lexical searches, word searches. This is for the embedding vector searches. So after we've created that, it's going to actually initialize it. It's going to create an object and save it off, this PG vector document store object. And then it's going to see if there's documents in it or not. If there are not documents in it, it's going to call and run the document converter pipeline, and it's going to try to fill it in. Otherwise, it's not going to do that, and it's going to try to run with the pipeline that you've previously put in there. I don't know if this is the best way to do it. It's certainly a nice, easy way to try to just give you a demo of how this works. So this is the basics then. You're going to do this initialize document store. It will in turn, if it needs to, call the doc converter pipeline, which will then run through this. This requires a little bit more explanation. So let me start with the easier one first, the create RAG pipeline. You can see that basically I've got two components. I've got a query embedder, which is going to be of type sentence transformers text embedder. And I've got a retriever, which is of type PG vector embedding retriever. And then you just connect them together and you pass that back out. Okay, right here, we've got a drawing of the pipeline that we just created for pulling the documents back out of the document store. You can see that it's very simple. We only had two components, the query embedder and the retriever. So basically you pass a query in, you embed it, you send it off to the PG vector embedding retriever, and it's going to come back with a list of documents. And that is, we take the top 5 in this case, and those are the documents that we just saw that came back where that was the strongest hits by comparison to the query. Now let me show you a diagram for the document conversion pipeline, and then I will show you the actual code. So you can see this one's quite a bit more complicated than the RAG pipeline. So you put a bunch of sources in, it runs it through an HTML to document converter, document being a Haystack document class that is specific to Haystack, so it knows what to do with it. What's going to come back out is a list of documents. I run it through a component called remove illegal docs, which is a custom component that I built that basically just removes documents that are blank. It runs through a built-in document cleaner class that Haystack has, a document splitter. It then goes through and it does embeddings. And finally, out comes a list of documents that go out to the document writer, which writes it out to the PostgreSQL database, and then we're done. Now you can see here that I am running the document converter pipeline now. So it's going to still do the same thing where it's going to run the query and it's going to do the embeddings, but you can see it's taking its time now to actually break up the federalistpapers.epub as we see it here, and it's going to break it up into 50 paragraphs or sub documents, document fragments, if you will, and it's going to embed those and it's going to store them out into the database. You can see that we're still at 0% because it does take a little while this first time when it's trying to embed everything. It's going to take its time, run the embedder, store it off in Postgres, and then we don't need to do that again once it's out there. All right, finally, let's take a look at the doc converter pipeline. So this matches exactly what you saw before. We created a series of components, converter, which is of type HTML to document, which is a built-in Haystack component. Notice that Haystack also has this add component built in. So what Haystack really does is it creates this graph of components that are linked together, and it creates a flow of information and then ultimately documents that come out the other side. You can include the large language model and its result coming out the other side as well. We've got this remove illegal docs. That was a component that I wrote, custom component that removes blank documents so that I don't have to put them in there. Cleaner with the built-in Haystack document cleaner. The splitter with the built-in Haystack document splitter. The embedder with the sentence transformer document embedder, which we installed. The writer, which is the document writer, built-in Haystack document writer. Notice that we've got a duplicate policy that we're going to overwrite. I could also have written a custom component to remove duplicates, but this is a great way of doing this. And then you just connect them all together. It creates that graph that I already showed you, and it's going to kick that out now, and you've got the pipeline. And then the final thing that you're going to do is in main. So what you're going to do is you're going to give the EPUB file path, so federalistpapers.epub, which I supply in the repo that I will give you a link to. So it's like right there, federalistpapers.epub. You're going to pass that into the Haystack PG vector class that we've been discussing. Table name, we're going to call it Federalist Papers. Recreate table, we're going to say false. We could say true the first time. You probably should say true the first time, but after that, I'm going to say false. We give it a query. What is the difference between a republic and a democracy? And then you simply call the RAG processor.generate response, give it the query, and this is what you saw as the result. It gives you the top 5 answers to your query. And that's it. We now have a semantic search pipeline that's over the entire Federalist Papers. It's stored inside of PostgreSQL. And if you've been following along with the videos, you basically have what you need for a RAG pipeline. Now, Haystack made this a lot easier, and it did a lot of the work for us. We could have written all this by hand, and I'll actually do a video where I show you how to do that, because sometimes that's very useful. But even in the cases where you need custom code, Haystack allows you to make custom components that can do whatever you want and then put them into the Haystack pipeline that you're going to run your documents through and you're going to get results out of. So I feel like Haystack's just a really awesome tool to be using. If you're going to be doing AI solutions like this, you really should become familiar with it. It's just going to make your life easier. It's not completely required, but it sure is handy to have, and it's another tool in your toolbox. And that's pretty much it. We've already now got a pipeline using Haystack that will actually retrieve semantic search for us and come back with document fragments that match our query. We are already almost done with our RAG pipeline. Really, the only thing we've got left that we need to add is the LLM itself. Now, this is a very simplistic pipeline. There's all sorts of things we could do to try to improve it and make it even more fancy, which we'll do in future videos and maybe an advanced version of how to build a pipeline like this. But we're only a few videos in and we're almost done. It's just not that hard. This is one of the things I've been trying to emphasize, is that AI is not scary. It's actually pretty easy if you're just a good programmer and you've got some basic concepts that you need to understand. So that's it for this video. Don't forget to like and subscribe, and we will see you next time.